sounds like you guys might have read those. So now we get to go ahead and, more or less just finish up where we left off in example 1 yesterday. So as you look, we started off, step 1, you got to identify your A value. Tell me what it does. In this problem here, A was a half. That's going to vertically shrink the amplitude of your graph. So the space between the high points and the low points isn't as drastic. The next thing you do is you pick out the B value. The B value in this problem is still the coefficient in front of X, but there was no coefficient there, so we can assume B was 1, which means that when we go to calculate the period, which is the next thing you do, you take your 2 pi, divide it by your B value there. Essentially, we take 2 pi and divide it by 1, because we said B was 1, so that's just 2 pi. The length of this curve from start to finish is still 6.28 units like it always is. Then we take a minute to find the left and the right endpoints, and you might recall from your homework last night, this is what you had to do. You had to find your left and right endpoints, calculate the period, and then tell me the transformations. So from your homework last night, you might recall that to find the left endpoint, you just take what's in the parentheses, which is this x minus pi over 3, and you set it equal to 0. And then to find your right endpoint, you take the parentheses and set it equal to 2 pi, and you just solve for x. So this graph is going to start at pi over 3 and stop at 7 pi over 3. After you find your left and your right endpoints, you then have to establish your quarter period. Because ultimately, we're responsible for finding 5 key points, not just 2 points, not just the endpoints. The quarter period helps you get the 3 in the middle. So you calculate the quarter period, 1/4 of 2 pi is pi over 2. So we had to add on pi over 2 each time to get from pi over 3 to 7 pi over 3. And that yielded a couple x values for us. So our 5 key x values are pi over 3, 5 pi over 6, 4 pi over 3, 11 pi over 6, and 7 pi over 3. So that is where we left off yesterday. So you see what's missing, right? The y values, how do you get those? Well, to get your y values, quite frankly, this process really isn't different than what we've done in the past. So if you'll look, the original y values for your sine curve go 0, 1, 0, -1, and 0. And at the beginning of the problem, you identified the amplitude to be a half. So to find your new y values for this particular sine curve, all you're going to do is take your original y values and multiply them by a half. So if it goes 0, 1, 0, -1, 0, you just take those values that I highlighted and multiply them by a half. 0 times a half, that's just 0. 1 times a half is a half. 0 times a half is 0. -1 times a half is -1/2. And then 0 times a half is just 0. And then you're going to see that this graph gets scaled by pi over 6. So after we get our 5 key points, we're going to go ahead and get our scale so that we can plot these points. So I'm going to go ahead and label a few more tick marks on the x-axis and a few more tick marks on the y-axis. Ultimately, how you scale your graph is up to you. After we finish the notes today, you're going to get a couple of problems to practice with. Well, that's also after we go over your homework, of course, but after we finish up our notes today, we'll go over your homework, and then you'll get a couple of problems to practice with. But ultimately, when you practice your problems, how you scale that x and y axis is completely up to you. Here, it's determined for us. Do you see it? It's pi over 6. So we're going to go 1 pi over 6, 2 pi over 6 is the same as pi over 3. 3 pi over 6 is pi over 2. And you see that I'm counting by pi over 6's, right? So 1 pi over 6, 2 pi over 6, 3 pi over 6. The next tick mark would have to be 4 pi over 6, right? That's just 2 pi over 3. You could do 5 pi over 6. 6 pi over 6 is pi. 7 pi over 6. 8 pi over 6 is 4 pi over 3. 9 pi over 6 is 3 pi over 2. 10 pi over 6 is 5 pi over 3. 11 pi over 6 is not reducible. And then 12 pi over 6 gets us to 2 pi. And then, you know, we have 13 pi over 6. So on and so forth. What do you think is a good way to scale my y-axis? Go ahead, Richard. By quarters. You could. Keep in mind, I am going to graph my original 5 key points on this thing too, which go up to 1. So if we go by quarters, I don't quite have enough tick marks to get up or down to the 1. If I were just graphing the transform function, well, yeah, then it'd be fine. So you want to give me another try? Okay. Yeah. Okay. So like that. We get all the information on there. Okay, so we're going to graph 2 sets of key points right now. We're going to graph our originals. You can always tell me to move, Rachel, if I'm in the way. So we're going to graph 2 sets of key points. We're going to graph our originals, and then we're going to graph our transformed equation. And then ultimately, it's up to you to be able to tell me what happened to our graph. What's different? So with that being said, let's graph our original 5 key points. Our original 5 key points start at 0, 0, and then we're going to graph pi over 2, 1, pi 0, 3 pi over 2, negative 1, and then 2 pi comma 0. So 0, 0, pi over 2 up to 1. At pi, we come back down to 0. 3 pi over 2 is going to bottom out at negative 1. And then at 2 pi, my period starts at 0 there. So I'm going to make that a dashed graph, because that's not necessarily the one that I wanted you to pay complete attention to. I wanted you to focus on how our new graph is different from the plain old graph of y equals the sine of x. So now I'm going to take a second to graph my new 5 key points. And I'll graph these in red for you. So I got to graph pi over 3 comma 0. 5 pi over 6 up a half. 4 pi over 3 comma 0. 11 pi over 6 comma negative a half. And then 7 pi over 3 would actually be the same as 14 pi over 6. That last little tick mark there. I have to stop now on the axis because it's at 0. So there's a couple of transformations that happened. That's what that curve looks like. All right, so what happened to my graph? How does it look different, the red one from the blue one? How do they look different? What do you think, Adam? Yeah, it's definitely not as steep as the other ones. That's very good. What else happened? Only one other thing, really, Joey. It moved to the right. Very good. It moved to the right. Okay. You can see, though, if you look, I'm going to go ahead and drag this. From end to end, the graphs are still the exact same length. Do you see that? Why did that happen? Michael? You're close. It is like one of those values in the equation. We talked about A because that was an amplitude change, and then Joey just told us it moved over. And that was the C value that did that. So we talked about A, we talked about C. Why did this graph stay the same length? Richard? Yeah, the period is 2 pi. The B value was 1, which meant that there was no horizontal stretch or shrink. So this period is actually exactly the same as our parent function, y equals the sine of x. So that's kind of that. You can really see quite nicely how the graphs are different. Go ahead, Richard.
This may just be a smidge off topic, but I'm just kind of wondering the application of graphing this. Like, I understand how to do it, but I want to know, like, what kind of problem
would you see? Okay, so we're going to do word problems in a little bit. But anything that follows sort of this cyclical pattern, like, you know, pendulums, you know, things of that nature, calculating the next swing for Tarzan on a rope. Anytime you talk about that sort of cyclical or sinusoidal pattern back and forth, that can actually be modeled by one of these curves. So when you go ahead and change maybe how high Tarzan jumps from the cliff or whatever to swing from tree to tree, or when you change you know, the weight on the pendulum, that's going to change the wave, the pattern through which the object moves through motion. So really, it's those kind of problems that we're going to take a look at in a little bit. As for right now, we just want to get the basics. How do you get the curve down? And then we'll talk about applications in the very near future. So we will do, before your next test, you'll have some word problems that you'll have to take care of using these. Okay? Any other questions? All right, so we got one more to do together as a class. In example 2, what's up? No? Okay. All right, last example in the note packet. We are going to repeat the exact same steps we just did. Start to finish, we're going to graph the equation y equals -3 times the cosine of 2 pi x plus 4 pi. So, step 1. So identify the a value. Little help. What is a in this problem? -3. Very good. Now, more importantly, that indicates 2 transformations of the graph. So what 2 things does an a value of -3 do to our graph? Good, Rachel? It's a reflection. Very good. And then Jaden, do you know what else it does? Oh, stretch. Yeah. The a value pulls out the amplitude. It's like stretching a rubber band real tall from top to bottom. It's the opposite of B and the opposite of C. B, if the B value is bigger than 1, that's a horizontal shrink. So that might have been what you were thinking of also. Yeah, it is a reflection. And this is also a vertical stretch. Okay. Next up, we identify our B value, and we use it. What is B in this problem? B, again, is the coefficient of x. Troy, do you know? Thank you. 2 pi. Good. This does a couple of things for us. It tells us if this is going to be a horizontal stretch or a horizontal shrink, and then it also helps us calculate what the new period is going to be. So just looking at this, 2 pi, it's definitely a number that's bigger than 1. That's 6.28. 6.28 is a number that's bigger than 1. Does this horizontally stretch or shrink the graph? What do you think, Shayla? I see you writing away over there. Yes. Okay. Then we can use this to calculate our period, how long the curve is going to be. From end to end, how long is this sinusoid? The formula to calculate the length of the curve is 2 pi divided by b. So we're going to take 2 pi and divide it by that b value of 2 pi. 2 pi divided by 2 pi is 1. So this curve is going to be 1 thing long. Now we could scale that, of course, but ultimately the curve is going to take up 1 unit, so to speak. Okay, so it's not a bad idea at this point in time to go ahead and, you know, sort of follow the steps that are on the previous slide. We would go ahead and take a few minutes. What we're trying to think about here, what are the 5 key points of this curve? So, you know, you might open up a set of parentheses for yourself, actually 5 of them. And after you identify what the period is, you can go ahead and start to think about the left and the right endpoint. So to find the left endpoint, all you do is you basically take what's in the parentheses right there and set it equal to 0. And I think we did this yesterday, but I'll do it again in case you weren't here. And then to find the right endpoint, you take your parentheses and set them equal to 2 pi. So this is what you did on your homework last night. You practiced just finding these endpoints for me. Then you're going to go ahead and subtract 4 pi from both sides. And then you're going to divide both sides by, if you want to get this x by itself, you have to basically divide both sides by 2 pi. So we can see that, your pi's go away on both cases. So the left endpoint is actually at -2. And the right endpoint is actually at -1, which makes sense because the length of this curve had to be 1. And the space that it takes up from -1 to -2 is actually 1 unit. So my left endpoint starts at -2, and my right endpoint sort of stops at -1. Questions about that? To get the points in between, what do you have to calculate? Important stuff happens every blank period. What do you think, Richard? Quarter period. Very good. So now I need to figure out, well, if the period is 1, what is a quarter period? So I got to take basically 1/4 of my period, or 1/4 of 1. 1/4 times 1 is 1/4, which means that to get from point to point to point to point, I need to add on 1/4. So -2, if you add a 1/4 onto that, and you could do it in fractions or, decimals would be fine in this case. It's a little different when we're talking about pi. Your decimals would be exact if you use them here, so I don't take exception to that necessarily. If you have -2 and you add on a 1/4, you're at -1 3/4, or -1.75. Add on a 1/4 again, you're at -1.5. Add on a 1/4 again, you're minus $1.25. And minus a 1/4 again, you're at -1. So it makes sense. By adding on a 1/4, I did get from the left endpoint to the right endpoint. So that lets me know I did that part correctly. And the last thing we have to do is calculate our y values. So if we look, this original function here is the cosine curve. And you might remember that cosine starts at 1. I'm looking at cosine right now. Cosine starts up at 1, goes down to 0, bottoms out at -1, and then comes back up. So the original y values for cosine, original cosine values, go 1, 0, -1, 0, and 1. So now I need to multiply all of those by my a value. My a value in this problem was -3. So I take 1 times -3, that's -3. 0 times -3 is 0. -1 times -3 is 3. 0 times -3 is 0. And then lastly, 1 times -3 is -3. You'll see that they scaled the x values for us. It's scaled by 0.25 or a 1/4. So if you repeat the scale over here, here's -0.25. -0.5, 0.75, -1, -1.5, oops, I'm sorry. Oh. So I just scaled my axis to the left there. And then according to this, the y values go anywhere from -3 to 3. And it looks like I have 3 tick marks along my y-axis there, so I would just scale those by 1s. And now I'm ready to plot my points. So if I plot my points, I have to plot the point first, -2, -3. So over -2, down to -3. The corner right there. -1.75, comma 0. -1.5, comma 3. -1.25, comma 0. And -1, comma -3. So there's your cosine curve. It's just upside down. And I'm going to look at the directions and make sure I have the complete graph right there. I do. It doesn't say graph it over multiple periods or anything like that. Sometimes when it says, you know, graph 2 periods, you kind of just take this wave and keep going. You know, so you would just kind of repeat the pattern to get multiple periods of this curve. Some of you were pretty good at this on that quiz. If you just keep going. All right, questions about that? All right, so that concludes our notes for today. What we're going to go ahead and do right now is talk about your homework.